Good morning, student. Today we will discuss ideal and non-ideal solution. Lecture 5 in solution chapter. So what do you mean by ideal solution and non-ideal solution? So ideal solution. And here we have non-ideal solution. Now, ideal solution means the solution which obeys the Raoult's law for the entire range of concentration. That is called ideal solution. That means first point, it obeys Raoult's law for entire range of concentration. So obviously, non-ideal solution means it does not obey the Raoult's law for the entire range of concentration. That means it does not obey. In short, does not obey Raoult's law. Now, it obeys Raoult's law. That means the pressure which is calculated based on Raoult's law and the experimental condition are same. That means P total equal to PA plus PB, and PA is calculated as PA equal to PA0 into XA. That means two components we have A and B. Similar way, PB equal to PB0 and XB. Addition of this pressure is equal to. Now here non-ideal solution. That means P total is not equal to PA plus PB. That means P total is not equal to PA plus PB. Okay. Again, PA is not equal to PA0 XA and PB is not equal to PB0 XB. That means P total is not equal to PA plus PB. That means it does not obey Raoult's law. That means P total is not equal to, that means here there is two possibility. Whether P total will be greater than PA plus PB, otherwise less than. So based on this, non-ideal solution can be further classified into two categories. That means it can be classified into two categories. The first one is non-ideal solution having positive deviation from Raoult's law. Positive deviation from Raoult's law. And the second one is having negative deviation from Raoult's law. That means negative deviation from Raoult's law. Positive deviation from Raoult's law, that means P total is not equal to PA plus PB. The possibility P total will be greater than. So here P total will be greater than PA plus PB. So when P total becomes greater than PA plus PB, so obviously here PA greater than PA0 except again PB greater than PB0 XP. That means positive deviation. Here negative deviation means obviously P total less than PA plus PB. That means PA less than PA0 except PB less than PB0 XP. So non-ideal solution having two types, positive deviation from Raoult's law and the negative deviation from Raoult's law. Now, second characteristic of ideal solution. So, delta H mixing. Delta H mixing equal to 0. Delta H mixing equal to 0 means when solution is formed, solid dissolved in solvent, then there is no evolution or absorption of heat during the formation of solution. That means delta H mixing equal to 0. In case of non-ideal solution, delta H mixing is not equal to 0. That means obviously again here two possibilities, whether it is greater than 0 or less than 0. So if delta H mixing greater than 0, delta H mixing greater than 0, that means it is positive deviation from Raoult's law. If delta H mixing less than 0, then it is negative deviation from Raoult's law. Delta H mixing greater than 0 means delta H positive. Delta H positive, that means here formation of solution is an endothermic process. Endothermic process, that means endothermic process means heat is absorbed. Delta H mixing less than 0, that means negative. Negative, that means exothermic process is the formation of non-ideal solution having negative deviation. That means heat will be evolved during the formation of non-ideal solution having negative deviation. Now, third characteristic of ideal solution, delta V mixing. Delta V mixing equal to 0. Delta V mixing equal to 0, that means suppose we are forming liquid solution by mixing liquid solute and liquid solvent. That means 10 ml solute is mixed with 100 ml solvent. 10 ml solute mixed with 100 ml solvent. Then the total volume of the solution must be equal to the 110. 110. Not it is greater than 110. Not it will be the less than 110. Exactly equal to 110. That means volume of solute plus volume of solvent is equal to volume of solution. That means in other words we can say delta V mixing equal to 0. Now non-ideal solution, so obviously here delta V mixing equal to 0. So here delta V mixing is not equal to 0. That means again two possibilities, greater than 0, less than 0. So here delta V mixing greater than 0. Delta V mixing greater than 0, that means 10 ml solute plus 100 ml solvent. Then volume of the solution will be greater than 110. Here delta V mixing less than 0. That means when 10 ml solute and 100 ml solvent are mixed, then total volume of the solution will be less than 110. Fourth characteristic, under which situation ideal solution are formed. So we are forming solution, that means solid is A, solvent is B. Now solid having intermolecular attractive force of this type, that means AA. That means between solid and solid molecules. Solvent having intermolecular force of B type, that means between solvent and solvent molecules. Now we are forming solution. When solid and solvent are mixed, solution having both solid and solvent, that means here new intermolecular attractive force is AB type is created. Now when this new and old intermolecular attractive force are equal, that means intermolecular attractive force AA and BB is equal to AB. That means old and new intermolecular attractive force are equal. But actually this is not 100% possible. That means in any solution this equal to is not possible. But in certain solution nearly equal to is possible. That means some solution having a nearly behave towards the ideal solution. 100% ideal solution is not possible. It is rare because old and new intermolecular attractive force never becomes equal. Now in case of non-ideal solution, so obviously this new and old intermolecular attractive force are not equal. So again two possibility, greater than or less than. So here. Now positive deviation. Positive deviation means vapor pressure is greater than compared to calculated from the outflow. That means when vapor pressure will be more, so obviously more vapor will be formed. When more vapor will be formed, the intermolecular attractive force will be less. That means here AA and AA otherwise BB. That means between solid and the solvent molecules, and here between solid and solvent molecules. That means in solution. So this new intermolecular attractive force will be less. This value will be less intermolecular force. That means less intermolecular force. That means you can write like this. This will be more. So less intermolecular. That means new intermolecular forces will be less. Therefore, more vapor will be formed and the vapor pressure will be increased. So obviously, in a negative deviation from Raoult's law, this AA or BB, this intermolecular attractive force is less, and the new intermolecular attractive force will be more. It will be strong. Intermolecular force strong, that means less numbers of molecules will be vaporized and the total pressure decreases. That means here AB more intermolecular attractive force. Now considering the example, then it will be clear for you. Again, 100% ideal behavior is not possible. but in some of the solution, nearly intermolecular forces becomes equal. Taking the example like benzene, benzene plus toluene. Benzene plus toluene forms ideal solution. Again, N-heptane, N-hexane, so many examples are there. Now, non-ideal solution. In a non-ideal solution, taking example, this intermolecular force will be strong. That means, suppose we are considering the example ethanol. Okay. Ethanol and ethanol mixed with water. Now, water having hydrogen bond, strong hydrogen bond. Water having the strong hydrogen bond. Now, when ethanol is added, ethanol also having hydrogen bond, but it is not stronger as that of water. That means when ethanol is added in water, that means new intermolecular force, that means between ethanol and water, is less compared to original. That means in hydrogen, in water molecules, hydrogen bond is strong, but when ethanol is added, then it is not found as strong as original. So ethanol plus water is an example of positive deviation. Again, suppose ethanol in which acetone is added, otherwise cyclohexane is added. Suppose ethanol plus cyclohexane, otherwise acetone. Then again here ethanol having hydrogen bond, but when cyclohexane, otherwise acetone is added, then a new intermolecular force will be weak. Weak, otherwise less intermolecular attractive force. That means this is also example of positive deviation. Now, in case of negative deviation, taking example of acetone. Acetone and chloroform. Acetone is polar molecules, chloroform is polar molecules. That means here polar intermolecular attractive force, and here also in chloroform polar intermolecular attractive force. But when they are mixed, this will be acetone, structure of acetone. Now when it is mixed with chloroform, that means CH, Cl, Cl, so hydrogen bond, this lone pair attract hydrogen of the chloroform. That means here hydrogen bond is formed. That means new intermolecular attractive force is strong. New intermolecular attractive force is greater, that means it is more strong, powerful. That means vapor pressure decreases. That means it is example of negative deviation. Again, nitric acid and water. Nitric acid plus water, HCl plus water, as an example of negative deviation from Raoult's law. Fifth characteristic of ideal solution. So ideal solution never form azeotrophs. They do not form azeotrophs. Do not form azeotrophs. Never form azeotrophs. Non-ideal solution, that means it forms azeotrophs. Now, solution which having positive deviation from Raoult's law. Positive deviation, that means vapor pressure will be more, vapor pressure will be more, that means obviously boiling point will be less. So this type of solution forms azeotrope but having minimum boiling azeotrope. It forms minimum boiling azeotrope. Minimum boiling azeotropes. So obviously solution having negative deviation from Raoult's law form maximum boiling azeotropes. Now ideal solution, non-ideal solution. Now this type of graph, when we draw the graphical representation, then we know the ideal solution graph is straight line. That means suppose we are plotting graph like this. For A and B, this will be vapor pressure and the mole fraction x2. That means here x2 is otherwise we can say xb. Here xb, then here xb equal to 0, xb equal to 1. Then here xa equal to 1 and then xb equal to 0. Suppose B is more volatile, then here pb 0. Okay, then the graph will be like this, and again this will be PA0. That means A is less volatile, B is more volatile, and this will be the graph of P total. This will be the P total, and this will be the graph of PD. This will be the graph of PA. This will be PB. So this graph is for ideal solution. This graph is for ideal solution. Now for non-ideal solution, the positive deviation from Raoult's law and negative. So here PA greater than PA0 XA. That means it will be like this. Again PB0. That means it will be like this graph. And the P total increases. That means it will be like this graph. That means this indicates the positive deviation. Positive deviation from Raoult's law. Now for negative deviation, vapor pressure decreases. So this graph will be like this. Okay. Again this will be like this, and this graph will be like this. So this graph will of negative deviation. That means in case of positive deviation, total vapor pressure is more than calculated from Raoult's law. This is ideal. And in negative deviation from Raoult's law, total pressure decreases. This is the discussion of ideal solution and non-ideal solution. I think